by 9. Combinatorial logic continued. This is Roy, and today we're going to continue looking at combinatorial logic, doing something slightly harder. In the last time we built different circuits using the gates we knew and or not. And the not and or NAND gate over here. And we use those to produce some sort of output, such as the case in this one that I'm approaching right now, where we said we only want the output on, which is the redstone right back there, if all 4 inputs are on, just like this. Now, I did receive one comment that it was difficult to see the lights that I was using, so I redid my resource pack to make something a little more visible for you. So, hope you enjoy. Now, the difference that we did here, these were all based on the input. So, only if an input was on. We weren't actually looking if we wanted to make sure if an output was off. So, you may want to consider a situation where you want to make sure that one of the inputs is off. Remember, we have labeled these as bits 0, 1, 2, and 3, which we are considering A, B, C, and D. The way we indicate that an input is on or a signal is received is we say the letter A, and the way we would indicate that it's not would be not A. It is the inverse. Now, that's exactly what we have here. This is the NOT gate that's inverting the signal. This is the on state, so when the switch is on, this comes on, like this. Now it's on, and you'll see that this state down here, that below, is off. So when it's off, this means the not A is on in this case. So we have A, and the top is lit, the bottom is not, and we have off, where the top is not and the bottom is on. What this lets us do is build a logic situation where we can look at having a certain input off, or not just on, but truly off. Now I'll give you a good example. Now let's say we want to build a circuit that can do something like this. So I'll put a sign down for what we're going to do. So we do a circuit where we have the A and the B signal are on, and we also want to make sure that we have not C and not D, like this. Okay, so what that says is the A signal is on, or we have the bit 0 is on A, B is on, but C and D are off. And we also want to say we want our output to be on if that or the opposite is on. So here we have not A and not B, and C and D. So in this case, we're actually wanting to say we want the signal on or output on only if A and B are both on and C and D are both off, or if A and B are off and C and D are on. Okay, we can go about building this particular gate is we have a couple ways we can build. We've got AND gates that handle this piece, and then an AND gate that handles that piece. And then feed those together since we have an AND there. Those would then feed into an OR, and we do the same thing over here. But because of propagation, I'll give you an idea. Let's say this is an AND gate here. I have another one here. I would have yet another one here for my third condition. And then I would have an OR gate somewhere in this area. So now if you think about the latency and how slow what redstone is and it moves forward, it has to move forward from here into this gate and into this gate, which occurred nearly at the same time. Then move one more step forward into here, and then finally one step forward from these two gates into here. So that's 1, 2, 3 levels of propagation. It'd be slower than if I just did a big 4 gate myself. So in other words, I have 4 input gates. So that means what we're going to do is we're going to create an A, B, C, D input for all of these, where we have a not A, not B, and a C and a D. And that's probably the easiest way to do this. Start about right here with an input. The next one's there, there, there. And then of course, to make it an AND gate, we go all the way across like this. Followed by the torches on the inputs. The torch where we want our output here. And then this will be our output. And of course, to complete it, we go across. So this is a 4 input AND gate. Right here. Now we're going to do this first condition here, the not A, not B, C, D. just because it's always good to keep track of what you're doing, it's going to do that right here. So this is going to be not A and not B. Also, with that, it's going to be and C and D. That's what this A and D is going to do. Well, our not A, if you recall, is down here. We want to connect that to this gate. So we start right here, line it up, come down to there. We want to make sure we go under this wire, and then bring it up into here. That's all we have to do for the A. Now for the B, it's going to be all the way over to there. That means we need to go under this wire. So if you count, it's 1, 2, 3, 4. That's what gets us under there. I like to get rid of all of these blocks that you can. For instance, this, so you can see the wire down there and keep track of it. That helps you debug later. So we go down underneath that one, and of course, as soon as we're down with that one, you start bringing it up. It'll be right there. So we get rid of this block, and then start bringing it up right here. And it'll come right into our. Looks like I missed one. What I need to do is bring it up a little more right here. So all of these will be one higher. And that'll get us where we need to be. There we go. Okay. That goes under. We will connect to this wire. Which will be right over here. It's going to connect into this one. You see we have a repeater in the way. So what that means we need to do is move the repeater back one. You don't want to move it forward, or you may weaken the signal. But as you'll see, that really doesn't matter all that much because you're moving all of these repeaters around anyway. So there we go. That's our not B connection. So there's not A, not B. You see that comes to the not B. And then we have the C and D connections, which are right here. The C is this top wire there, so I'm going to use a branch here. It'll be the same thing over here, but I have to go to the D. D is the fourth wire. 1, 2, 3, 4 on the top. And to do that, we just go bridges over there. This is the C. And this is the D right here. And all we do is wire this up. And that gets us to the C and D wires for this first. The second condition, we come back over here. It is going to be the opposite. So in this case, it's going to be A and B and not C and D. So I'm going to need another one in this case, which we go right alongside this one. We'll put it right here. Once again, our 4 inputs. And then we build the gate. If you get good at building these, you end up building a lot of these. Anytime that you build any kind of complicated circuit, of course, our torch will move our output to there. Now recall, with this one, I'm going to label it right here. This is going to be A and B, and not C, and not D. So it'll be the opposite. A is very easy, it's sitting right here. So we just bring this 4 and 3 to there. B is right there, so it's a bridge in that case. Very easy to do. And there it is. And then of course the only tricky part to this is getting the not C, which is going to be this down one, and the not D is that one. So if you recall, what we need to do to get underneath of these wires is we go down 4 straight there. There's 1, 2, missed 3 and 4. So that's as far down as we need to go and replace this mistake that I just did. So bring the redstone down. Once again, I like to see my wires. So there it is. Let's put these down to where I can see them. Remember, we're going under this one too. This is the B dot wire. We want to get to the C, which is the next one. And right after this one, you start moving up. So put this there. We can hear that one. Now that the way you can do this is connect just like that. You go down and up. So that is the not C. And then the last one, of course, is not D. Same thing. I'm going to go down. To 4. I'm going to get rid of all of these pieces. All the way underneath here. To the D, which is going to be 2 over, so we want to go under this next wire as well. Here, make sure we're connected back there. Down to here, pick it up, and we can start coming up at this point. There it is, and we're connected. So there we have the not C and the not D. As you can see, this one goes over to the C, and this one goes over to the D. In this case, we have not A, not B, C, and D. Now, the last part of this is you can see it says that it is either this condition, which is this gate, or this condition, which is that gate. So we need an OR gate between these two. There's a couple of different ways to connect that up. And the easiest way in this case is bringing in from the sides. Now you don't actually have to have any block that is a valid OR gate, but because it does symbolize, there's normally logic you need a gate for this in electronics, I go ahead and put a gate in. It makes it pretty clear. And then I'm going to elevate the output of this so you can see it easier. It goes up there. We've got it set. Now, all we have to do is check all of our wires and make sure they have their links. So what I'll do is I'm going to get my coordinates here and see where we're at. Around, I think I'll go to that right here. We are at 11:15:146. So I'm just going to teleport to that real quick. Teleport to 11:16, just one higher, and 146. That put us right here, and then of course our switches, where we want to go, is at 20, 20, 20, and there we are. Now I can get back and forth very easily. So recall that if this one and this one are on, and this one and this one are off, we should have a light. That means to check out our wiring. We're going to go back, and we're going to take a look. This wire should be on. Oh no, actually we have the top, and it looks like we have some repeaters out of place all the way back here. So we just start wiring up and fixing these problems as we see them. And we end up eventually running to here. I take out any repeater that I can, because each one has a latency. So I always optimize them as best I can. And then we have the same thing going here. This repeater needs to be 2 back. And they will have to catch probably all of these. We'll do the same thing. And here. Okay. That gets us our A and B, which goes over to this gate. We want to make sure we have power all the way across. So we have power there, but we're lacking power right here, so I can just put a repeater right there. Doesn't really matter where, but in this case we've got it. And then of course we have the not C and not D. These two should be lit up here, and we should be catching them underneath. That one is powered, that one is powered, but at some point they're going to signal. You can see this one's already at 2 right there, so I'll repeater. I missed by 1, but that'll work. Alright, and same thing here. Looks like this one's dying right here. So we've got that. And now you can see that this gate is now has an output of 1 or on power, and so is this one, because this one is capturing the not C and not D, and the A and B. And this one has got the not A and the not B, but there must be a problem because this gate should not be on at this point. And it is because we are lacking power. So as you can see, we don't have everything powered the way it should be. The not C and the not D are coming to here, not C and not D to there. Okay. The reason we have power to this part is because of that switch. Or excuse me, not that switch, but because we have power. As I said, it's draining all the way over here. But this gate is not on. You can see that the gate is on, the torch is lit. Alright, we just need to check that side too, so we teleport back to our inputs. And we reverse them. So this is going to be off, off. This is going to be on, on. Go back to our gates. And once again, we check out the wires. Now this time, this is the one that should be positive. We have not A, but you can see the signal is dying right there. I can't put a repeater here. I'll show you what happens. It can't get a signal from down there, so I have to put my repeater down here. Like so. This one is good. It's got power all the way here, so all the ones we have to check are these. And we are good there. But we are not good here. Once again, I cannot put a repeater here on the end because power doesn't transfer down. So instead I put it here. Now, this gate is on, and that feeds into the OR to terminal light. So now both my conditions are met. So I go back to the inputs. You can see our light. Let me line up with it. It's this one right there. It's on right now because our conditions are met. There's C and D, not A and B. If I turn either one of these on, see that light will go out. It did right there. It's now out. Because the conditions are not met. I can turn this on, same thing will happen. You can see that it's not on. Same thing here, because both of these must be off. As soon as I turn this one off, you'll see that it'll move and propagate down there, and the light is on. So that's a simple circuit. It's just for our testing to learn how to do this. Let's do something a little more complicated this time. Go a little bit further down. Okay. Now in this case, let's do a different circuit as a test. We're going to do a circuit where we have either A is 0 and B is 0, so they both must be 0. So B and B0, which is bit 0, B3, or A and D, okay? A and D have to be off, and either, but only one of C and D. So let me write that on a sign right here. So we're going to say our first condition is that we need not A and not D. And the second thing is, and we have either B or C, but not both. Right, should indicate to you this is going to be an XOR gate. So not A, not D, and either B or C, but not both. All right, let's start with our gates. Now I'm going to move over here a little past these circuits, these repeaters, to make it easy to connect. And we're going to do the same thing. The gates start right here. All right, our first condition we'll do right here. That is the not A, not B. This is simply going to be a 2-input gate because it only has those two. It's going to be not A, which is down below. So get my wire. There we go. Not A. You can see it's connected, but it is already losing signal, so we move our repeater back to here. You'll find this happens a lot. You end up moving a lot of repeaters. Okay, and then of course my missing connection is there. This is the not A, and of course since this is an AND gate, we said we want these conditions to be met. Not A and not D. It works there, and we'll put a piece of wire right here. There we go. Now this is going to go all the way down underneath to D. And you just follow that through. One more. We have to get under the A, and once we're under it, we can start bringing it up. I just disconnected this one. I can certainly tell when I heard I picked it up. There we go. Looks like we lose power somewhere at this point. Right, so the output of this gate is on because we do have... Oh, it was supposed to be D. I keep getting these wrong, so we'll go on. This has to stay down. There it is. And the reason it's not connecting is we have a repeater. As you can see, it has to be moved anyway. And we'll do a teleport back to the switch. Then we'll turn off D. That's what we're after this time. And go back. So this one needs to go all the way to D, which is all the way back here. So we keep this down below. And the connection will go to here. Once again, we move repeaters. And check the length of this to make sure it's powered all the way. It is not, of course. That is right there. Put a repeater in and we're good. So now we have this gate active. This is the not A and not D. Don't need a switch there. We need a sign. Not A and not D. Now this other one is an XOR gate, as you recall. They're the hardest to build. Once again, it'll be a 2 input. We build them like this. Get torches. Here. Bring this wire out with torches. Got this one wrong. Like so. Wire on top. 2 blocks there. Torches. Wire on top. And finally, our output of this gate. There we go. Now this is going to be, back to our original specification, we want either B or C. So that means these are going to connect to the upper B or C. There is B and C is on right now. So that means a bridge. Same thing here. Connect everything up. And we check our power. We see that one dies there. There we go. And they're both on because we have exactly the conditions we want. We have A is off, D is off, and either B or C, in this case C is on, so you can see that our gate is good. And then that last condition over here is either, or it's an and. You see this one and either of these, so I need an and gate. That means both of these would have to be somehow connected, just so you can see. Oh, I can't do it here. Move it up 1. We'll bring this over and we'll connect it into the back like this. Once again, this side is fine, but just for demonstration purposes, I'll do it this way. Now this is an AND gate. Should be able to build these by now. And we'll once again elevate our output so that we can see it. I'm going to make this 1 higher. Right here. So we can see it over that one that we just built. Okay, there we go. So once again, not A, not D. Those are connections down below. There's the A. All the way back to the not D. And then either B, which is here, or C, but not both. So the last thing we have to check is make sure that this line is correct. So we go back to our switches. Here we are. We'll turn on the B. Our light should go off at this point. If I built the XOR correct. And we'll check the length of all of these. So this is the B line here. And you can see that it's died right here. So we put a repeater. And there we go. Looks like we got it. Now it's off, and the reason it's off is because while we still have not A and not D, they are off. Both B, as you can see here, and C are on. And if they're both on, then this gate won't come on because it's an XOR gate. It requires one or the other, but not both. So we can start going down and taking a look at our switch, see what Now you can see it's this light right there. It's the tallest back there. Turning any of these turns on. So now you can see I have not A, not B, C, and not D. Turning on either of the outsides will cause the light to go off. It's this one. Do the same thing here, turning that on. Not going to matter. Turning this one off. Light stays off. Because they both have to be off, and one of these sender two on. Both going to cause the light to go out. You can see that it had right there. That's how this works. And the other thing you want to notice is this other circuit that we built is this light right. It's the lower one, just behind it. It's still going to work. You recall what it is either both of these are off and both of these are on. And you can see that it lights. So our new condition, this light here is off, the tall one, but this one is on. So the nice thing about circuits, of course, you can satisfy multiple conditions off the same inputs, which might be something that you want to do. You can see that this is on. And the other thing you might see is as you change switches, let me turn this one off, our second light should come on, because as you can see it would mean that A is off and D is off, and then only one of these. So this will cause it to light, and there it is. Now, different combinations can cause that light to blink on or off before it finally comes to a resolution. I don't know if there's any in this circuit, but you will definitely have where you'll see it'll switch states. And that is normal, because anything takes a little while to propagate down the line for it to come on. And so I have the both outsides on. As soon as I turn this one off, the other light from the first circuit will come on. And that's how this works. So that is using negative conditions. Once again, that's the two circuits that we built today. They can get very complicated. I have a couple more that we'll build, but they're going to be a little more complicated, and they're going to be a lot easier to see another way. So in our next lesson, we're going to have an introduction to a logic simulator, which is a program that will let you build these and build very complicated circuits and test them before you actually come to the build stage. Because they can get very confusing in Minecraft, as you see. Let me look up here. You can see the different connections and wires. If you had a lot of these, and you did, and just imagine if you had more gates coming from here, if your combinatorial logic was very long, you end up with a lot of wires and connection to do this. So that is our lesson for today. Next time we will take a look at the logic simulator. Hope you enjoyed. See you soon.